So we'd like to begin our study of graph theory. This is our last unit in the course, the fourth unit. So the first unit was finance. The second unit was voting theory. Third unit was counting. And finally, we're here at graph theory. So we want to define what is a graph. So we have some terminology to develop here, quite a bit of terminology. So definition. What is a graph? So a graph, so we're defining, consists of a finite set of points, consists of a finite set of points called vertices. And lines connecting the points and the lines connecting the points are going to be called edges. Edges. So a graph is made up of two things, vertices and edges. Let's just do an example here of a graph. So here I'm going to have, this is going to be a vertex, another vertex, another vertex, another vertex, another vertex. So these are my points, these are called my vertices. Let's label these A, B, C, D, E. And we'll make some edges. These are just some lines that connect some of the vertices. Okay, so this is an example of a graph. We could draw this a little differently. So what matters here is the vertices and the connections between the vertices, the edges. Let's see, so let's say this is A, B, C, D, and E, let's say. See how this works out. So we know A has to connect to B, right? That's this edge. B has to connect to C. It's this edge. C has to connect to D. That's this edge. D has to connect to A. We could do something like this, right? We could make it go around. We just have to make sure there's an edge between the two. It doesn't have to have the same shape. B has to connect to E. Where could we do that? B connects to E. We could do that right here. And then we have to make sure that D connects to E. We could just go right here. So this is another way to actually draw the graph. This is the exact same graph. We have the exact same vertices and the exact same connections, the exact same edges. So the edges are the connections. Yeah. So this is the same graph. If we call this graph over here G for graph, this is the same as G. This is the same. Strange, right? Strange. I mean, the point is you got the same vertices and the same connections, the same edges. Okay, so here's a definition. What is a path? path is a sequence of edges in which no edge is repeated. No edge is repeated. So you're not allowed to have an edge repeated when you're dealing with a path. So let's look at an example of a graph here. Example. Let's say this is A, this is B, this is C here, this is D here. We have an edge between B and D. We have an edge between A and D, and let's put another vertice down here. E. And let's list some paths from A to D, vertex A to vertex D. So one path would be from A to, well, let's use a different color, red. A to B, and the way we'll designate that, we'll list the vertices in order to designate the paths. A, comma, B, and then from B to C, and from C to D, and then from D to E. So that's a path. Let's try another path. There's other paths to get there, right? We could go from A to B. We could go B to D. And we could go from D to E. So we're listing actually the sequence of vertices, that take us through those edges. To complete the path, right? Or we could also take, here's one more path we could take. We could go A to D, and then just go directly D to E. And I believe there's still one more path we haven't done. We could go A to B, then we could go B to D, no, we can't go there. Yeah, we'd be in trouble. Yeah, so I mean, if we kept going forward, well, that's what path we've already taken. We've already taken that path. I think that's it. I can't think of any other paths. Remember, you're not allowed to repeat edges. Okay, so that's it. I think that's all the paths. Let's see. Here's another definition. A graph is connected, so we're defining connected if there is a path between any two vertices in the graph. There is a path between any two vertices. In the graph. So let's look at an example of something that's connected, or maybe not connected. Say I have a graph like this. V1, V2, V3, V4, V5, V6. So this is all one graph, but notice you can't get from V3 to V4. So this is the graph, I'm going to call it G, G for graph. So G is unconnected. And that's because there is no path here, right? From V3 to V4. Since there is no path, from V3 to V4 between those two vertices. Okay, what about another example? V7. V1, V2, V3, V4, V5, V6. This whole thing is called G. This is connected, right? You can get from any vertex to another vertex by taking a path. Yeah, every 2 points that you take, you can travel between them along a path. So G is connected here. Okay. We want to define what is a bridge. What is a bridge? Definition. A bridge in a connected graph. So you have to be dealing with the connected graph to even talk about a bridge. A bridge in a connected graph is an edge that, when removed, causes the graph to become disconnected. A bridge in a connected graph is an edge that, when removed, would result in the graph being unconnected. Let's do an example. Okay, I have some vertices, V1, V2, V3, V4, 5, V6, V7, V8, and connect that to V5. So actually we have a bridge right here. So V4, V5, put those together, that's an edge, is a bridge. And it turns out that's our only bridge, right? If you remove that, it's going to result in a disconnected graph. Let's do another example, see if we can find any bridges. Let's see. So we have what? A, B, C, D, E, F are our vertices. What are our bridges here? Well, AB is a bridge, right? If you get rid of that edge between A and B, so imagine you were to get rid of it, then it would become disconnected because A is isolated from the rest of the graph. So you need that. Oops. So, AB. What else? Well, if you got rid of BC as well, right? If you took away BC, you'd result in a disconnected graph. So BC. What else? If we took away, for example, CF, we'd have a disconnected graph because F is not connected to the rest. So CF is a bridge. And how about here? CD. Take away CD and you get a disconnected graph. So CD is important. It's a bridge. And also if you were to get rid of, just imagine getting rid of DE right there. You'd have a disconnected graph, right? The E would be disconnected. So DE is a bridge. So in this case, every single edge, these are bridges. Okay. So I think what we'll do is stop right there and just take a moment to pause.